Hello and welcome to this video in the series on right-angled triangles. This video is following on from the previous couple of videos and is about finding an unknown side using trigonometry with right-angled triangles. So we're going to go back to our old SOHCAHTOA word that we learnt a video or two ago. So SOHCAHTOA. Okay, because that is going to help us with our problems today. Okay, so if you remember back to some of the other bits and pieces, we always start with naming sides. So what we're going to do is we're going to look at this first example. And name all the sides. So here we are. I'm just going to change my pen color. There's our angle that we're using. So this is our relevant angle. That's our relevant angle, so that's the one that we're going to take all our information from. Here's our right angle, which makes this line over here the hypotenuse. Okay, and then based off the angle that we have our adjacent side, which is the one next to it, and then our opposite side. So now that we have all that information, let's go and have a look at our question. So our question is, find the length of the unknown side x in the triangle shown. Answer corrected to 3 decimal places. So what we want to do is we want to make a note of what we know. So we know that the angle of theta is 35 degrees. We know that the hypotenuse doesn't have a value, so I'm just going to leave that with a question mark. Okay, we don't know the value of the hypotenuse. If we get asked about that later, we can probably find that out. We can definitely find that out, but we're not actually asked about the hypotenuse. The adjacent side is 20, and the opposite side is our x. Okay? So because our adjacent side is 20 and our opposite side is our x, we want to use the tan ratio. Okay, so we are using the opposite and adjacent sides. So that's our TOA section. I don't know if you can see that yellow very well. So we're using our tan ratio. So we go tan of theta equals opposite over adjacent. So a couple of things here before we keep going. I've written down all the bits and pieces of information that I know, so I can use them in my problem, and then I'm starting with my formula. I already have a diagram, so I don't need to redraw the diagram. Now I just need to use all the information in a formula, and so I write down the formula that I'm using. This is going to become tan of 35, and that's going to be x over 20. X over 20. So now we have everything in there, and we just need to do a few steps to get to our answer. What we're going to do is we're going to get x equals 20 tan 35. Now you're probably going, wait, what the heck just happened? And that's okay if you are. So what's actually happening here is we have gone to multiply both sides by 20. So we've just used some basic algebra and multiplied both sides by 20. So it becomes I'll just pop it over here. Okay, so that's all it is, and all I've done is I've switched sides on the equal side, because all that equal sign mean is that both sides have the same value. That's it. Doesn't matter which side they are on. It's just easier to have your unknown or your subject on the left. Now this one to 3 decimal places, because it's in an approximation. 3 decimal places is going to be 14.004. Alright, let's look at this second example. Alright, our second example here is find the length of the unknown side x in the triangle shown, corrected 2 decimal places this time. So this time, our relevant angle is here, so it's in basically the same spot. But this time we actually don't have the adjacent side anymore. What we do have though is the opposite side and the hypotenuse. Okay, the adjacent side is blank. We don't have that, but we do have the hypotenuse. So our theta is 34 degrees for this one. The hypotenuse is 25. The adjacent side is not given, but the opposite side is our x. So based on our SOHCAHTOA, we're going to use the sine ratio. Okay, so we're going to use sine. So let's get started. The first thing that we're going to do, well, we've got a diagram. We don't need to draw that. We have all of our relevant information. So I'm going to start with the formula. So sine theta is O over H. Filling in that formula, and then we follow the exact same process that we did in the previous example. Okay, so we multiply both sides by 25. Alright, so we multiply both sides by 25 and we get x equals 25 sine 34. Okay, so then we work that out correct to 2 decimal places. 2 decimal places. And we'll get 13.98. Alright, so that's doing the unknown side where we have the unknown on the numerator of the fraction. Okay, so the unknown's in the numerator for those 2 examples. Our next example, though, is going to have the unknown in the denominator. So instead of it being on top, it's going to be on the bottom. Okay, so here's our example. Find the length of the unknown side x in the triangle shown, correct to 2 decimal places. So we go through those same processes as before, Relevant angle. We need to take note of. And then our sides. So we've got H for hypotenuse, O for opposite, and A for adjacent. Okay, so for this one, our theta is 40 degrees. Our H is X. So we automatically know now that we're not going to be using tan because we don't have the opposite and the adjacent. We have the hypotenuse as one of our sides, so we can't use tan, so that's already automatically out. Our adjacent side is given us as 12, and our opposite side has not been given. So that means that we're going to use cosine or cos. Okay? Because we have the H, the A, so then we just need the C. All right, let's get into this example. So we have our information, we have our diagram. Our next step is a formula. All right, so there's our formula, and now we just plug into that formula the information that we know. And you can see there that there's a little bit extra to this one, simply because our unknown is in the denominator this time. So in this little section here, all right, what we're actually going to be doing is we're going to multiply both sides by x, which is going to give us x cos 60, or 40 rather, x cos 40 equals 12. Now that's not really helping us because we need to get x on its own. So our next step using some general algebra is to divide by cos 40. Okay, so dividing by cos 40 gets us the x equals 12 over cos 40. And as you can see there, it's essentially a straight swap It's a straight swap of places, the denominator and the part with the angle in it. Alright, so it's just a straight swap of places. So what we're going to end up with over here is go straight to x equals 12 on cos 40. So that bit in pink and green is that missing step in the purple, is that little gap there. Okay, you can write that gap out if you want to, or you can just recognize that the x and the cos 40 have just simply swapped places, and I go from there. So then x is going to equal, once we plug that all into our calculator, 15.66. Hopefully this has given you a little bit more information on using trigonometry and applying it to some triangles. Hopefully this video has helped you out with that. Good luck with some of your questions, and thanks for watching.